Now, what we need to think about here is, okay, what was the next step I've done? Well, the next step in this process has been we need a null distribution, right? That was always our next step. Give me the null distribution, right? I need to know what it should look like if there's no difference, right? So let me write that out as a sentence. So we have our sample. We can actually look at these numbers, but it's not very helpful unless we know what our sample. Now, I was about to try to italicize these with my hand, but my brain is not going to be able to do that, so I'll just put it in quotes. What our sample should look like. Maybe look like should be in quotes. It doesn't matter. You know what I'm trying to do. What our sample should look like if our null hypothesis is true. If really, there's no difference between men and women in terms of the average number of close friends. Right? We got to know what this looks like. We have to know what we should be expecting. Because the whole point of this is if we can know what this picture, because we're going to need a picture, should look like, then we can take our actual sample and compare. Right? And guess what? We've done this a bunch. It sounds just like we did before with one variable. Right? It's the same thing. We spent all that time before with one variable. Get me your null distribution. This tells me what should, most of the time, I'm doing air quotes here, you obviously can't see, what should happen. If our sample fits the picture, we're like, okay, null plausible. But if our sample is way out there, if we simulate many times and never get our sample, or only get something kind of like our sample or more extreme a few times, then whoa, we would have to be pretty crazy lucky to have had that happen. And we don't play that in statistics. That's not an acceptable answer for us. Oh yeah, I got crazy lucky. No. Right? If we hit that threshold that we've talked about before with the significance level, then we're going to say reject. So if our sample here that we calculate, which we'll do in just a second, is too extreme, we're going to reject the null and say, nope, we've got evidence that there is a difference between the average number of close friends of men and the average number of close friends of women. That's our goal. So let's just do it, right? We can do this. So we're over here. I'm going to hit use data. We get some nice pictures here. And then we get something really important here, which is the actual statistic. Now, it's not done here directly, but we can just kind of read off. And so let's just do that. So let's get our statistic so you can see what it looks like just to put this together. So this is, well, I already forgot, right? This is why you write stuff down. The average number of close friends of men minus that of women. Okay, so let me just rewrite it here so we have it. All right. Now let's read it off here. Men is 1.86. So in our sample, the average number of close friends for just the men in our sample was 1.86, a little under 2. For women, though, it was 2.09. So the average man from the sample had 1.86 close friends. The average woman had 2.09. This is negative 0.228. And just check that out. It's here, right? You know, they give it to you right here, which is nice. But, you know, we'll just do it by hand real quick. So what does this mean? This negative means that this number was bigger. In our sample, women had more friends on average by 0.228 people, which is nonsense a little bit, but it's an average. So it's less than 1, closer to 0. So you might be thinking just like, oh, that's not a very big difference. Well, that's why this is, hard to do just in our own heads. Do some simulation and see if this difference really is not very much or if it really is pretty big. Because I think it's hard to do just in our heads. So let's do that together. We go over here and we hit the Show Shuffle Options button. All right, and then we're going to scroll over here. Now, remember how this works. It's very similar to before. We are going to do some amount of shuffles. And in the book, it goes through this where, what are we really doing when we shuffle? Well, what we're doing is, right now, each individual person in our sample has a sex, men or women, and a number of friends. And these are connected together. Now, the whole point is, we think there might be a connection between your sex and the number of friends you have. It is, we think, somehow related, men and this number of friends. We think that there's some kind of relation happening here. So how do we simulate no relation, right? Zero, no difference. It doesn't matter, men, women, it's the same average number of friends. How do we simulate that? Well, we got to mess all these up. We disconnect the sex and the number of friends. Disconnect them, shuffle up the number of friends, and give each new person a different number of friends. I mean, technically you could get the same number of friends, of course, but we're going to randomly give them a number of friends. Let's just do that once and see what happens. So we do a random shuffle, and look at what's happened. These men are still the same ones, but now I've shuffled up the number of friends they've gotten. Now, the first man has 0. Oh, that was the same. The second man has now 2, and then 1, and then 0. So we've shuffled them all up, shuffled the number of friends up. And the goal of doing this is to disconnect the two variables, sex and friends. If there was a connection before, maybe women on average have more friends, or men. Who knows? But if there was a connection, hopefully us shuffling up has broken that connection. Now, if it actually broke the connection, we expect then that when I recalculate this statistic between these two groups, I should get close to 0. And look at that. Puts it right here. I'm close to 0. I expect it to be close to 0. Is it going to be 0 every time? Of course not. There's still a little randomness in here, right? But we expect it. So we could do this a couple more times. Why not? Let's do another one, and another one, and another one, and another one, and another one. And you see what's happening, right? Sometimes the sample of women has more friends. That would be over here. Sometimes the sample of men has more friends on average. So let's bump this up. We've done 5 already. Let's get this weak stuff out of here, doing one at a time. And let's shuffle up big time. All right, so we've done it now a total of 101. Whoops, I did it too many times. That's okay, 101's fine. So we've got 101 total shuffles now. What does this mean? Let's just take a stop here, right? So what have I done here, right? What are these 101 blocks? Well, remember what these are. Each one of these blocks represents a new shuffled sample of the men, the women, but we've shuffled up the number of friends they've had to try to simulate no connection between sex and average number of friends. Close friends, sorry. So what do we notice? Well, I'm getting a picture I'm used to here. You might be bored of this picture already, but that's part of the point. It's centered at 0. What happens as I leave 0? I'm getting fewer and fewer of these blocks, aka samples, that hit those values. These are less likely to happen than these, assuming no difference. So then it just comes down to, like it, we've done many times here, we can put in our actual sample, 0.228. Here we're going to do beyond, because beyond, remember, means I don't know if men have more friends than women or less friends on average. I just want to know if they're different. The two groups are different. So beyond does two-sided. And here's my p-value. So I get a p-value here. And my p-value is 0.0396. And just as reference here, 4 samples. That's it. 4 times out of 101 total did we shuffle this up and end up getting a statistic that is as extreme or more extreme than ours. Now, I didn't mention what alpha was when we were doing this, so we can assume it's 0.05. What does that tell us? Well, our p-value is smaller than alpha, so we're going to reject this null, and we think there's a difference between the groups. We're saying, oh, we're pretty confident there is a difference between these groups. This analysis alone does not tell us exactly what the difference is, or if we even know which group we think there, has more friends or less friends. But we've got some evidence that there is a difference between men and women in terms of the average number of close friends they have. So there you go. So just an idea of kind of how this works. And so just to kind of summarize, we've got the data. We can calculate the statistic on each of these, but we put them together by subtracting to get our actual one single statistic. We can then simulate the null distribution, aka what it should look like if there's no difference. And when we do that, we get this picture we're very used to. We can compare our statistic to it, find the p-value, and make a conclusion.